webinar on introduction to the blockchain and its application. Welcome to Dr. Chirag Modi, who is the speaker of today's webinar. Dr. Chirag Modi is an assistant professor in the Computer Science and Engineering Department, National Institute of Technology, NIT Goa. Sir completed his PhD in 2014 from the NIT Surat. Sir awarded as the youngest scientist in 2015 in the specialization of cloud computing by the Venice International Foundation, Chennai. His area of interest is the blockchain, cryptography and network security, information security and privacy, cloud computing, visual computing. Sir have a very good, powerful research background and have a good publication of the research paper. So without further ado, we are starting with our webinar. Welcome, Dr. Chirag Modi.
Yeah, thank you for my introduction. Yeah, so in today's webinar, we'll see the foundation of the blockchain. So that how blockchain was initiated, how it is working, and what are the techniques which are playing the major role in the foundation of blockchain, and followed by its applications. So these are the contents of today's webinar. So first we will see the blockchain, its working, how cryptographic techniques are used into the blockchain. Then we'll see its various consensus mechanism, followed by its applications. So blockchain is the merger of three main engineering stream, that is software engineering, game theory, and cryptography. So software engineering is always required to develop the software. So blockchain is also a part of the software. So here software engineering play a major role. Game theory, as blockchain makes the decision among the untrusted entities in distributed environment. So let's say suppose 10 people are there and 10 people would like to choose one particular person who is the winner of that particular event. But those 10 people are not trusting on each other. So this is like a problem of the game theory. So game theory is also playing a role. And for securely sharing the data among these entities, we need the cryptography. So cryptography is also playing a major role. So blockchain, I can say it is a merger of three main engineering domains like graph theory, software engineering, and cryptography. So how blockchain were initiated? So early days we had the centralized system to perform the transaction among the entities, but there was not transparency and people were not trusting on each other. Centralized system is working well where trust is involved among the entities and everyone is trusting on some centralized authority. So they are believing that if I will perform transaction, it will reach to my receiver. And that belief is established by the centralized authority. But now in today's world, there is no trusted entity. And it is difficult to trust, and there is always a fear if I will perform a transaction and my transaction database is maintained by the centralized authority, whether my database will be secure or not, whether my database will be available after 50 years or 100 years or not. So here blockchain is playing a major role. So blockchain is nothing but to maintain the multiple copies of same database among the number of entities. So if anyone is trying to modify the one copy, it will not reflect to the other copies, so that modified copy will be invalidated. So this is the concept of blockchain. So transaction system needed to be decentralized. It requires the transparency. As in distributed environment, as I said that there is no trust among the entities, so transparency can help to achieve the trust among the number of entities, and it should be incorruptible. Incorruptible means if I am performing transaction with you using the centralized authority, if centralized authority is modifying the transaction, then there will be big loss. So this system should be incorruptible, and to fulfill this, digital currency played a major role. So digital currency allowed for the instantaneous transaction and borderless transfer of the ownership. So if you want to perform the transaction from one border to the another border, then you can easily transfer. You need not to rely on the centralized authority. Here, Bitcoin play a role. So Bitcoin was proposed on October 31st, 2008 by the author Satoshi Nakamoto. So this was the paper presented by the anonymous author, and this Bitcoin is a purely peer-to-peer electronics cash or digital asset transfer system. So earlier this blockchain was used only for performing the financial transaction, but as financial transactions are in the form of the digital data, so data can be anything. So this concept can be used for the various application. But Bitcoin can be considered as a birth of the today's blockchain industry. And after that, many blockchain platforms have been evolved like Ethereum, Hyperledger, IOTA, Ripple, Coda. The concept behind, characteristic behind among these blockchain platforms are same. Only the underlying techniques are different to achieve the trust among the untrusted entities. So there is no proper definition of blockchain is available. So still a blockchain definition is not standardized, but as per its characteristic or as per its working, blockchain can be defined like a distributed database. So blockchain is a distributed database with that means the copy of database is available to the all the entities which are involved into the blockchain network. This database is practically immutable. Means once you have loaded or you have pushed the data over the blockchain, it cannot be changed, and this will be achieved using the cryptography. And this database will be maintained by the decentralized peer-to-peer network and through the consensus mechanism. So that means suppose if there is a distributed copy of the database, means every node is maintaining the copy of the same database, then how to push the data? So for that they have to run some game theory mechanism, and then everyone should be agreed to push the data, then the data will be added to the blockchain. And then how data will be pushed to the blockchain or how data will be ordered? So data will be ordered in the form of blocks, and each blocks are the link to the each other. So this linking we'll see later. And these blocks should be these blocks are the I can say that consist of the number of transactions. So transactions should also be validated. So let's say the working of the blockchain. This is common workflow of the blockchain. Consider there is a transaction initiator and receiver, and always in a transaction system there will be one sender and one receiver. And as I said that blockchain is having the peer-to-peer network instead of the centralized authority. So transaction initiator will initiate the transaction and will send to the peer-to-peer network that I want to perform or I want to send this data to this particular receiver. This data can be anything. Data can be the digital currency or data can be any message. So this data will be sent to the peer-to-peer network. Now every node in peer-to-peer network will receive the such data. So they will receive the certain amount of data from the number of initiators, and once the certain amount of data will be taken by the any number of nodes in peer-to-peer network, then they will start forming a block. So forming a block requires the certain number of transactions. Once the certain number of transactions are received by the block, then the block will be formed. Now creating a called block mining. Creating block is not a simple task. Otherwise, everyone can create a block. So this requires some computational effort. So this computational effort we'll see later. But for time being considered, the block is generated by the number of nodes. Once that particular node is creating a block or mining a block, this block will be published in a network saying that this particular node has created a block. Now this block will be validated by the other nodes, whether this block is valid or not. So other nodes will verify whether this block is genuine or not. How to check genuinity, that we'll see later. Just see the workflow. So once the other nodes are giving confirmation that this block is genuine block, then and then only this block will be added to the blockchain. Now the condition to see that whether this block is genuine or not, the condition is that the hash of this current or new generated block, the hash value of this new generated block should be lower than the previous block in the blockchain. This is the condition. And the beauty of the hash function is that it is easy to calculate the hash value of given data, but it is very difficult to calculate the L to the target value. So here our target is what? The new block hash value should be lower than the previous block hash value. So that is very difficult and for that computation required. So all nodes may not be successful after applying in computational code, that block, that node with a winner push the data. And others will block hash value lower than this block value. They will check on this part. And then they will give the confirmation that this block is genuine and it should be added to the blockchain. Once that block is added to the blockchain, receiver will get that message. So this is the block structure in the blockchain. So here if you see this magic number is showing the network, version is showing the which blockchain platform you are using, and here sender and receiver should operate on same platform, and that is why interoperability issue is in the blockchain. Block size, previous block hash value you have to consider in this block so that other nodes can check that this block's hash value is lower than this previous block hash value or not. Merkle root is the part of this transaction list. So transactions, the number of transactions will be ordered in such a way that it will form a tree kind of structure, and the root of the tree, the root value of this tree will be stored into this block header. Then timestamp, at what time this block is generated. Difficulty target is showing that how much preceding zero should be there. As you are increasing the number of preceding zeros in this block's hash value, means this block's hash value will be lower than the previous block hash value. So if you see all these component of this block structure, no component can be changed. Magic number you cannot change, version you cannot change, block size you cannot change, previous block hash value you cannot change. Merkle root is dependent on the number of transactions, that value also you cannot change. Timestamp you cannot change. Difficulty target you can change only nonce value. So if I want to make this block hash value lower than the previous block hash value, what I have to do? I have to change the nonce value every time, and I have to check whether this block hash value is lower than the previous block hash value. Once that node will be successful at particular nonce value, making this block hash value lower than the previous block hash value, that nonce value will be recorded, and then this block will be published into the peer-to-peer network. So these are the building blocks of the blockchain. First is the magic number, which is the identify the blockchain network, that in which network this transaction should be propagated. Block size, it was usually 1 MB. However, it is increased to the 2 MB. Now blockchain is to be used for the various other applications which we into more transactions. That is why block size is increased to the 2 GB. Version, each node has to implement same version of the node. Then timestamp, target, and nonce. These three parameters are required to mine the particular block. It is using the hash function. So this will see that how it is using the S function. It requires public-private key pair and it is using the elliptic curve-based digital signature algorithm. So you know that public-private key pair are used for what? Suppose if I am the transaction initiator, then nodes should verify that who is initiating the transaction. So later repudiation cannot occur. So it will help to achieve the non-repudiation in the blockchain network. So if I am initiating the transaction, I will sign that transaction using my private key, and my public key is known to the every node. So using my public key, nodes will verify that from where this transaction is coming. So later I cannot deny that I did not perform the transaction. And for signing that transaction, elliptic curve-based digital signature algorithm is used because it is providing the same security level like RSA with smaller keys. And that is why elliptic curve-based digital signature algorithm is used. In blockchain, nodes are there. So nodes are what? The number of computers registered to perform the mining of the block or to validate the block. And each node, whoever is generating the transaction or whoever is receiver, they should have wallet. So wallet is a software which is installed in your computer or your handheld devices. Smart contracts are optional. So smart contract we'll see later because smart contracts will be required. Suppose if I want to perform transaction to you, but before performing a transaction, if I want to put some business logic, if I am eligible, based on some condition, so I can write a code. So whenever I am initiating the transaction, my transaction will go to the smart contract. Smart contract will see whether I am allowed to perform the transaction or whether I am fulfilling the required conditions. Then and then only I will be able to perform the transaction. So smart contracts are optional. And proof of work. There are many consensus mechanisms. So we'll see the proof of work and other consensus mechanisms later. This is the structure. If you see that, as I said, that blocks are cryptographically back referencing. So block 9 is linked to the block 10, block 10 is linked to the block 11, block 11 is linked to the block 12, and block 12 is linked to the 13. This linking is provided based, this is logical linking provided based on the S function. So this linking is saying what? This block 10's S value should be lower than the block 9's S value. Now consider this block 11's S value is lower than the block 10's S value. And this is the Merkle tree. So consider this node, a particular node has received the 4 transactions, transaction 0 to the transaction 3. First of all, S of each transaction will be created. Now S of this S's will be created. At the end, you will reach to the root of this Merkle tree, and this root will be added to the block header. So if somebody trying to modify any of the transaction, saying that I perform to transfer the 2 Bitcoin, but if somebody trying to modify this transaction, and the beauty of hash function is what? Even if you modify the single bit in a given data, it will completely change its hash value. So even if you modifying the single bit in any of the transaction, it will modify the hash of the complete block, and that hash of the block, that hash value of this block 11 may not be the lower than the block 10's hash value. Ultimately, what will happen? This block 11 will be invalidated. Due to that, block 12 will also be invalidated. So here, using this, it is providing the immutability feature. So how cryptography is used into the blockchain? So as I said that for initiating the transaction or broadcasting the transaction, cryptography is used because when I am initiating or broadcasting the transaction, I need to sign that data. And for signing that data, I need the public-private key pair. Validation of transaction will be happen through the consensus mechanism like proof of work. So this consensus mechanism we'll see later. To perform the consensus, here cryptography is used. And chaining of the block. For chaining of the block, hash function is used. So already we have seen that how blocks are chained. So these blocks are chained logically through the hash function. So we'll see that digital signature and public-private key pair. So these pairs are used to create the wallet and signing the transaction. So consider in a Bitcoin, first of all, when I'm installing my wallet, I will provide my identity to the wallet. But as you see in our normal net banking, when you are performing a transaction, your original identity will not be revealed. Only your account number will be revealed. So this account number is your public key. So this public key known to everyone so that people can perform the transaction. But using your account number, nobody can derive. Nobody expect this central authority or bank. Nobody can derive that who is having this account. So here using the wallet, when you are installing wallet, that wallet will generate the pseudo random number, and from this pseudo random number, it takes the initial 80 bytes, and on this initial 80 bytes, it will apply the SHA-256 function. So this will create the 256 bit. Now from this 260 bit S value, first 4 bits of S value will be added at the end of this random number. So what your random number wallet has generated, this wallet with this wallet number, first 4 bytes of this S value will be appended, and whatever this output is there, this output will be converted into the base 28 string, and this is called as wallet import format private key. This is your private key which should not be revealed. If you are revealing your private key or if you are losing your private key, later you will lose your whole amount which is in your wallet. So you should not reveal your private key, or you should not lose your private key, because the beauty of beauty of the blockchain, once you are losing the private key of your wallet, you will not be able to access the wallet, or you will not be able to recover the key. Why they have put this thing that recovery mechanism is not there? If recovery mechanism, if they would have put, then anyone can recover your key. There may be many network attacks can be possible on your wallet. So once you are losing your key, then nobody can recover that key, and you will lose your whatever money you have in that wallet. Now to produce the public key, you know that elliptic curve, that once I'm having this private key, I will choose one generator on the elliptic curve, and this key will be scalar. This key will be applied to the point over this elliptic curve, and this is what scalar multiplication. So this capital K equals to the small k into the point over elliptic curve. So this is showing the scalar multiplication over the elliptic curve, and which is producing my public key. Now this public key will be as using the SHA-256 algorithm. So it will again generate the 256 bit my public key. This output will be again as using the RIP-MD 160 bit as algorithm. So again it will generate the 160 bit. So my final output will be converted into binary value, and this is my unique address. So my unique address size is 160 bit. So this is my unique address, which is like in our normal terms, it is like my account, I can say address. So this account number 160 bit will be known to the everyone. So if anybody would like to perform the transaction with me, they can know only this 160 bit. They cannot know that who is performing transaction, because we are initiating this transaction and we are broadcasting this transaction into the peer-to-peer network. So all the nodes in peer-to-peer network, they can know this only 160 bit. They cannot know that who is initiating transaction. Means identity of the sender or receiver will not be revealed, and this is what anonymity. This is what it is achieving, the anonymity of the users. So how hashing is used? So hash is also a cryptographic term. So we have already said that to generate the wallet addresses, hash is used. So hash is used for encoding the wallet address. It is required to encode the transaction between the wallets. So this we'll see in the next slide. And it is required to verify validity account balances of the wallet. So hash will also be required to see the integrity of the data. and mining. To mine the block will require the hash function. So the base of the blockchain is a digital signature algorithm, elliptic curve cryptography, and hash value. So if you want to implement your own blockchain, at least you should be clear in these three cryptographic terms: elliptic curve cryptography, hashing, and digital signature based on the elliptic curve. So how transactions will be signed? So hashes are often used in the combination with the signature. For example, a certain user is the owner of the input corresponding to the certain hash. So signing input is not efficient. Therefore, signatures signing the hash, because even if you are signing the transaction, if transaction is modified, means your signature is suppose modified, that signature will be invalidated and you will not be able to perform the transaction. So to maintain the integrity of this data, we need to apply the hash. So hash of a transaction gets generated by user A using private key. That hash will be signed. So that one proper hash value will be received by the node in the peer-to-peer network. Then and then only that transaction will be considered. So how mining will work? So I will directly jump to the proof of work. So as I said that every nodes are collecting the sufficient number of transactions and they are forming the block. So consider this is proposed new block and header of the most recent block. That is the hash value that is the previous hash value of the previous block, and the nonce value. As I said that what we can change every time, nonce value. So every node will apply the try and error method. And you know that to calculate the 256-bit hash value using the SHA-256 algorithm, it takes the computational effort. So here for every try and error method, it takes the computational effort of a node. So this will combine and this will generate the hash number. Now if this hash value is less than the target value, then it is considered that that node has solved this problem. Otherwise, every time it will increment the nonce value. So this is try and error method. Now let's say for a nonce value 14, this node is successful. Once that node will be successful, it will broadcast this block into the peer-to-peer network that I have solved this problem. And other nodes will validate whether this block's hash value is lower than the previous block hash value or not. Only this thing will be checked and they will give confirmation. Once the 51% of confirmation from the total number of nodes will be received, then this block will be added into the blockchain and this particular node will get some reward in the form of some coins. Why this reward is given? Because this node has put its computational effort. This node is spending time. If you will not announce the reward, then network stability will not be there, and later no node will be there to perform to validate the transaction or to create the blocks, and that is why reward is considered. So in literature, there are mainly 5 types of the blockchain, but widely blockchains are these initial four, like public blockchain. So you know the better example of public blockchain is the Bitcoin. Private blockchain, if you are creating a blockchain for your organization only, and outside of your organization should not be allowed in your blockchain network, then it will be considered as a private blockchain. Permission blockchain. Let's say, suppose I am creating the blockchain for KYC verification. So KYC verification, in that user's document should get verified the particular banks, not by the particular user. And so to register as a node, banks should have to take permission from central authority, RBI, saying that I should be the validator or I should be the miner of this block. Give permission to become a node. So here RBI is centralized authority. RBI will say RBI is just giving permission to a particular node registering in peer-to-peer network. So to become a node in a peer-to-peer network, each must take permission, and there are centralized there. But to perform transaction or to create the block or to validate the block and to establish to maintain the blockchain, it is decentralized structure. So permission blockchain is working for this. Permissionless, any node can be registered to the peer-to-peer network without taking the permission from any of the other nodes. So let's say Bitcoin. When you want to become a node or miner in the blockchain, you need not to take permission from any of the authority. Consortium. So this is the combination of the public and private block. Like suppose if you do not want to mine block in a public network, so at backside you can create the private blockchain. You can mine the blocks. You create the private blockchain, and this data you can later reflect to the public blockchain. So this will help to improve the speed of the transaction. As I said that we have already seen a proof of work mechanism. In proof of work, we have seen that a number of nodes are trying to create a block and they are putting their computational effort. And whoever will be successful on that node's block will be added into the blockchain. Means other nodes resources will be wasted, and that is affecting the scalability and speed, because it requires the 51% of the nodes confirmation to add that block into the blockchain. So instead of this, Ethereum blockchain has come up with the proof of stake. So here if you see this platform, Bitcoin, Ethereum, then Ledger, then Ripple, then Oda, then Intel. If you see that they are differing based on the consensus mechanism and storing the block, but the concept behind all this platform is concept in the sense the characteristics to achieve. So design goals of all these blockchains are same, only they are differ based on the consensus mechanism and blockchain structures. And these different blockchain structures and consensus mechanisms are proposed to improve the speed of the transaction. Proof of work is too slow, but it is giving the good security among the untrusted entity because it requires 51% of the confirmation. And proof of stake will replace the computational work with the random selection process, where the chance of successful mining with proof of stake is proportionally related to the wealth of the validator. So if having the more number of I can be the miner. So here, instead of instead of considering the computational work to mine a block, here the wealth of the validator is considered to mine and validate the block. Then Byzantine fault tolerance. In that, it requires the 2/3 of the network to behave honestly. But again, here instead of considering the 51% of the confirmation, it is considering the 2/3 of the network. 2/3 of the network confirmation. So in this case, again the problem is if this network size is increasing. Network size is increasing in the sense that the number of nodes are increasing in the peer-to-peer network. Again, same problem like proof of work will come. So based on that, various other consensus mechanisms are there. Most widely used consensus mechanism is the proof of authority. Like, so I'll tell one example. Like in your organization, suppose principal is the authority, but principal is granting the special permission to all the HODs to upload the students' result over the blockchain. So only who is the miner? Those HODs only, and those HODs will validate the transaction in the student. They will verify student data. They will create the block and they will add this block to the blockchain. No any other faculty, no to be part of this consensus. and this is what the authority. So here only few number of nodes will be involved. So again you are decreasing the size of network to validate or to mine the number of blocks. So again it will create the security issue. If consider among 6 HODs in your organization, 4 are not behaving honestly, or 4 are relevant, or they are related to the particular, so they can push the wrong results if this will meet, but still chance is less. So time to decrease the number of nodes to validate, it will affect to the security. Security in the sense validation of the data. And if you are increasing the number of nodes, it will affect to the speed and scalability. So this is a trade of the consensus. As I said that whatever node is successful, that node will get some reward. So to get a reward, you have to spend something. So in proof of work, nodes are spending their computational effort. In proof of work, the nodes will spend some money. That let's say suppose like a poker game. Every node will spend some certain amount. Whoever will be successful, that node will get reward. And whatever you have spent to become a miner or validator, those money you cannot reuse again. So in proof of work, you have to spend some coins, and if you will be successful, you can get your coins back with some reward. If you will not be successful, you will lose your money. In proof of capacity, instead of spending computational effort, your coin, say that I'm having the large space, and whatever nodes are having the large storage space, those nodes those nodes should be allowed, because if storage space is less, then they cannot maintain the blockchain, because blockchain is database, so they cannot maintain the blockchain for a longer duration. So these are the various consensus mechanisms. If you want to do research, you can come up with a new consensus mechanism for solving the speed scalability issue while considering the trustworthiness of the data among the untrusted entities. So how to generate the trustworthy data among the untrusted entities? This is the problem in the blockchain consensus. This is the problem of the consensus. So overall, if you see that, as per the Gartner report, it is saying that blockchain will create the $176 billion business value by 2025 and $3 trillion by 2030, and growth rate 40%. And you know that currently this is a blockchain's hype, and till 2030, its growth will be increased. It is same like the cloud computing. As you know that cloud computing was initiated in mid of the 2006. It became too popular. Researchers have done a lot of work. Now it is a mature platform. I'm not saying that nobody is working, but it is now mature platform. So similarly, blockchain is at the initial stage in the IT industry, and it will take at least 10 years to become a mature platform. And these are the various platforms are available all over the world. These are the consensus mechanism which we have seen. If you see the projects, US is dominating. As per the literature, it is saying that US is dominating the blockchain market. Means they are having a lot of projects, around 40% of the projects on the blockchain. And these are the major sectors considered to apply the blockchain, like smart grid, transportation, in academia also to put your degree certificate or to put students or faculty, to maintain the students or faculty's credit score, supply chain, land registry, oil and gas. So if you see all these sectors, if I will pick the smart grid, so this sector is consists of the different entities from the different domains. And as I said that blockchain should be applied where untrusted entities are involved. If all are trusting on each other, we need not to apply the blockchain. So if you pick any sectors in which if you are seeing that there are number of untrusted entities from the different domains, then better to apply the blockchain. In India, these are the major companies which are actively working on the blockchain-based projects. Some are working on creating the new platforms of the blockchain, and some are working on the use cases of the blockchain. These are the government initiatives. So I'm not going into the detail of the government initiatives. But in India, land registry, IP management, in the academia sector, e-governance, e-KYC, energy management, asset management, industry automation, and supply chain. So these are the major sectors considered where you can apply the blockchain. But blockchain is not coming with only benefit, it is having a lot of limitations and challenges. First of all, we have already seen that it is having the problem of the speed and scalability in contrast to the centralized system or our normal web services. It is having the interoperability issue. It is having the laws and regulations issue, governance issue, because if something is happen to the data in the blockchain, then who will be the responsible person? It is difficult to apply this. So governance issue is also a problem. Acceptability. So if you are developing a platform or if you are developing a use case over the blockchain, it is difficult to convince the client because client may not be aware about this. So testing is important when you are developing any use case or application. You have to test all its feature and then you can convince to the client. So it requires the in-depth feasibility analysis before you apply blockchain or before any industry apply blockchain to any use case. It requires the in-depth analysis. And as per our observation, we found that only if it is mandatory to use blockchain, then you move your business to the blockchain. Business in the sense any application. But many organizations, due to the technological hype, currently they are spending a lot of money and effort to work towards the blockchain. And that is due to the technological hype to compete with the others, saying that we are working on the recent technology so that they can get the more clients. But it requires careful analysis and risk assessment, because if blockchain is not required, and even though if you are applying, it will affect to your scalability and speed of the transaction. And our traditional systems are also working well, but in traditional system it is difficult to establish the transparency, it is difficult to establish the trust among the untrusted entity, and blockchain can be the solution for those problems. There is a need to understand the business requirement. If you are not understanding the application requirement, let's say e-KYC. E-KYC you can perform over the online. Then why it is required to apply the blockchain? So you must have to understand the requirement or challenges of our traditional e-KYC, and then you can move to the blockchain. So that will save your effort and money. So this money is relevant to the industry people when they are developing the blockchain use cases. So these are the major applications. So financial sector I will not cover because we have already seen that Bitcoin is working well and many other coins. But if you see the smart grid, so I'll cover the smart grid. Earlier days, I'll cover smart grid later. Then supply chain management, pharmaceutical supply chain management, identity management can be one of the applications. So identity management for the KYC process, citizenship record maintenance, vehicle registration, construction. We are going to cover in this webinar. Then license agreement. So if you see the license, when you are going for taking your home on rent, you are making a license. So, but both the parties, tenant and owner, both are relying on the lawyer. A lawyer is creating the stamp paper and he signs. Suppose tomorrow if lawyer is dead, they will be the responsible if some disputes are occur. So there are many things in license agreement which can be resolved using the blockchain. Then in government sector, ticket booking, so many other applications. But if you see all these applications where multiple entities are involved, where multiple entities from different domains are involved, and where untrusted entities are involved. And if you are having such kind of entity, then better to move for the blockchain. In smart grid, I will cover this small example. As you know that nowadays people are putting solar panels on their rooftop, and they are able to generate the energy. And if they are generating excess amount of energy, they can supply this energy to their neighbors or into the smart grid, and later they can get the incentives. But in smart grid, like region wise, there is a trading platform. Means one region can be participate, and if that region is generating excess energy, then whatever region is having more demand, they can purchase the energy. But consider there is a competition among the four regions. Four regions need the energy, so always we should have to do some trading. So this trading can be happen over the blockchain, that the suppliers will supply the energy to the grid saying that I want to sell energy at this particular rate. And consumers will bid the energy that we want to purchase energy at this particular rate. Now, so supplier will supply the energy using the energy injection contract. Consumers will bid the energy using the bidding contract. So why we have considered the contracts here? Because we have to put some business logic. Whether this consumer should be eligible to put a bid. So this eligibility we can consider based on its regular usage. Then over trading platform, we can run some auctioning policies. So there are many auctioning policies are available in game theory course. You can apply the better auctioning policy, and you can create the win-win situation for the supplier as well as the consumer. Means suppose if I want to sell a energy for a particular rate, let's say 55, and consumer is bidding the energy at the rate 60, and if he is winner, then we can take the average of these two to suppose let's say 57. So at 57 rupees, the consumer will get the energy. So here it is a win-win situation for both supplier and consumer, because supplier wanted to sell at the cost of 55, consumer wanted that energy at the cost of 60. And we have considered in auctioning policy, we have considered the average of these two. So that means consumer will be benefited by the 3 rupees, while supplier will be benefited by the 2 rupees. So this is win-win situation for both of them. Why it is required to maintain the win-win situation? So that both can participate in future to make this network active. So if you want to see these kind of use cases, you can refer my papers. In supply chain management, here I have considered the example of the pharmaceutical supply chain management, but you can consider any of the example in supply chain. So there will be always raw material supplier. Using raw material, manufacturer will manufacture the product. It is going to the distributors. From distributor, it is going to the retailers or end users. So this is the supply chain. And for every transaction, like raw material supplier will supply the raw material, so that record can be maintained over the blockchain. Manufacturer are supplying this item to the distributor, that record can be maintained. Here logistic is also playing a role. Once the quality and quantity, as per the agreement, if proper quality and quantity is received by the receiver, then and then only automatically money should be deducted from manufacturer wallet to the supplier, from distributor wallet to the manufacturer, or from hospital or retailers to the manufacturer. So blockchain is playing a role in the sense that a user can directly purchase the item from the manufacturer. So here it will cost of that particular item. Let's say Amazon, but Amazon is not the manufacturer. So Amazon is the distributor platform among the manufacturer. But if I want to directly purchase from the manufacturer, I can through such platforms. So if you want to see such supply chain management, read my white paper that I published for the food grain trading for the chain. So for that you can refer to my Google profile. Vehicle registration system in which also multiple trusted entities are involved. So many first owner of any vehicle manufacturer will sell that vehicle to the dealer. Dealer will sell that vehicle to the customer. To do all this process, we require the service record, we require the insurance record, we require the police record, and the RTO registration. Now let's say that manufacturer is selling this vehicle to the dealer.